So we're going to take a look to continue here on example 6. Example 6. Now we haven't sorted a combination yet, so this is permutation. But I want to ask if somebody could tell us all, please, why is this example permutation? Now, again, I'm telling you it is, but I'm asking, why is this an example of a permutation? Vanessa?
Because you have to do the position of where it is.
Good. And in this example, what do you have? What's the scenario that's going on right now?
I can't see that far.
Okay, it says, how many, so you answered it without even reading this, wow. It says if there are 16 students in Mr. Smith's class, but only 10 desks, how many different ways can the students arrange themselves? So you're arranging yourself, right? So if I arrange myself, or if Trayvon and John were to switch seats, isn't that a different arrangement? Think about it logically. Vanessa just moved up to the seat. Isn't the classroom now in a bit of a different arrangement, just from one person moving? So the placement of her body in whatever desk it is affects the arrangement of the room. So the order in which you guys are set up does matter, or else it wouldn't make any sense, right?
Right.
If the order didn't matter, even if you changed spots, they would all be the same then, if order didn't matter. But since order does matter where you sit, it is a permutation, because order does matter. Order does matter. Next, it says, there are 16 students, but only 10 desks. So somebody tell me what N and R are in this problem. What N, Trayvon, and R are.
N is 16.
Good, and?
R is 10.
Very good. Because N is the number of choices. There are 16 students to choose from where they're sitting. How many desks are there though?
10.
And the 10 represent the amount of slots to fill. Remember we talked about slots? So R is simply 10. And this is going to be the amount of slots that you're filling. So we have 10 desks open with 16 people. So first of all, how many people are going to be standing? 6 people, right? Clearly there's not enough desks. We could be doing that, but as far as desk arrangements go, okay, we have 10 people seated. So, we want to look at this kind of a problem, and we want to think about what's going on. Can there be any repetition in this problem? Remember we talked about repetition versus not repeating.
No.
No.
Why is there no repetition? Yeah, you can't have the same person in 2 different seats. Remember, repetition means that person A would be here, and maybe here. But can John clone himself? Maybe not now. Maybe not. But right now, John cannot clone himself. Okay? You have his foot up on the chair. But his nature body, right, can only be in one seat. It's only be in one seat. So there's no repetition. What did I say yesterday? If there's no repetition,
Then you can use calculator.
you can use a calculator. If there is repetition,
You can't use
you
calculator.
can't use a calculator. Very good. Good memory there. So what do we do? Very good. 6P10. And on your calculator, let's do this all together again. 16. I said 6. Thank you. I wrote 16. So on our calculator, we're going to see we have to type the 16 first, like we talked about yesterday. So start by typing in 16, and press math. Go over to your probability. So let's do this together so you can see it. I start by typing in whatever n is. I press math. I'm going to press left to quickly go over to probability. Then go to NPR. Enter. Then I press 10. Enter. Now I did this problem on purpose because a lot of these issues, or a lot of these examples with combinations and permutations, give scientific notation answers because they're such large numbers. What does this e to the 10 mean at the end? Awesome work. Wow. Well done, sir. Well done. This is scientific notation, which you call exponential. Same thing. Exponential scientific notation. It really means 2.90594,304 times 10 to the 10. That's what e to the 10 means here. This e to the 10 is indicated by this. So as Trayvon said, this means we're moving the decimal. Good try there, Jay. Good try to say it. Moving 10 spots to the right. 10 spots to the right. That was close. So 1, 2, 3, 4, 5, 6, 7, 8. Well, once I move it 8 spots, what do I have to do to get the last 2 spots?
0.
Just tack on 2 more zeros. So we've got 2905, 94, 304, 00. Again, this is 8 spots. I need 2 more spots. There's the 1, 2. So I have to put 2 more zeros in there. So put my commas every three digits. How many combinations do I have here? Or how many? Wow. Permutations do I have here?
29 billion.
29 billion different arrangements. So if you had 16 students in a classroom with 10 desks, you could arrange yourself in 29 billion different ways. Is that interesting to think about?
Let's try it.
You know how long that would take?
The whole rest of the school year.
Why? Let's think about this for a second. Why is it this way? Why?
Wait, what?
Why is this number so large? We want to think about, right? Why does our answer make sense? We can't just assume it's right.
Because, like, you have to think that every single person is doing every single thing.
Yeah, so, for example, Victoria, in your desk, if there's 10 desks and 16 people, how many people can sit here, really? 16 different people, right? Then how many people can sit here? 15, because no repetition, right? Once the person sits down, they're stuck there. 15 here. 14 can sit here, right? 13, 12, 11, 10, 9, 8, 7. That fills all 10 desks. So if you multiply 16, 15, 14, 13, all the way down to 7, isn't that going to be a huge number?
Yeah.
So what you're really doing is what we said as our formula. You don't memorize this now. But you're really doing 16 factorial over over 6 factorial. Because the formula, and again, you don't have to memorize this, but I'm just telling you, is n factorial over n minus r factorial. So this is really 16 all the way down to 1. This is really 6 all the way down to 1. So if I think about it this way, 16, 15, 14, all the way down to 1. This is 6, 5, 4, all the way down to 1. Aren't all these 6, 5, 4, 3, 2, 1 going to cancel up here also?
Yeah.
So that's why we're left with 16, 15, all the way down to 7. Because the 6, 5, 4, 3, 2, 1 cancels with the 6, 5, 4, 3, 2, 1 up here, and thus we're left with 16, 15, 14, all the way down to 7, which is what we just did by looping around those 10 desks. How do I get the 6? N minus r factorial is part of my formula. N was 16, r was 10.
Oh, okay.
16 minus 10 gives me the 6. Okay? Again though, you don't need to memorize this formula. I encourage you for once not to. Okay, not to. It's good to understand how it works, and that's how it works right there, but there's no need to actually memorize. Okay? There's no need. Alright, let's go back to our problem now. So we end up getting around, I'm going to put an approximation here, around 29 billion. All right, now we're switching gears, and we're moving over to combinations. We're moving over to combinations. Now, the first example we're going to do is with repetition. So can I use my calculator?
No.
I cannot. So this is one of those times that you're going to need to know a formula. And it looks very complicated at first. But it's actually not that bad. Okay? It's actually not that bad. Yeah, I mean, you're just memorizing with a minus 1 up top and a minus 1 down below. So that definitely helps. There's little tricks to memorize this stuff. Okay? So first, an example of a combination with repetition might be choosing 3 scoops of ice cream. And think about it for a second. Okay?
What flavors do you have?
If you have a ton of different flavors, right? So say you have Baskin Robbins, you got 31 flavors. Okay?
Ritas.
So you got 31 flavors in front of you. You choose 3 scoops. There's nowhere that it says you can't choose the same scoop twice, right?
Right.
You can choose chocolate. You can choose chocolate vanilla strawberry. You can choose cookies and cream, mint chocolate chip, and coffee. Okay? You can mix it up. You can repeat. So we have repetition. Now, and I know this is going to be a little bit different, but the order here doesn't really matter. I know for some of you guys you might say, oh, it sure does. I want to do this first. But realistically, the order doesn't matter. In the end, you're still getting 3 scoops of whatever you chose, right? It does not matter the placement of the order here. It doesn't really matter. Just like, remember the Mega Millions example we did? If you win Lotto, or if you get any of those numbers, it doesn't matter if the first number they pull is a 2, but you pick 2 as your 4th number. It makes no difference. You don't have to pick it in the correct order. So if I pick 1, 2, 3, 4, 5 as my Lotto ticket, and the Lotto draw happens to be 5, 4, 3, 2, 1, I still win. The order does not matter. That's one of our prime examples we're going to see. But with that example, there's no repetition. You should have the same Lotto number twice. Remember that? You're picking out of a hat. And once you pick that number, it stays out. So you can't repeat. So we're going to start with repetition, then we'll look at the lottery one to see where we have without repetition.
I saw everybody is great, and then the dad got mad because his lotto numbers were wrong. It was the same numbers, but it was flipped. And he was mad.
It's just an episode of TV. It doesn't matter what order you pick. It does not matter. Now, I'm sure there are some lotto games, guys. Like, for example, if you've ever gone with your parents to a restaurant, you see there's a very popular game that people play called Keno, or Quick Draw is another one, where they're on like a little TV and they pick numbers. Maybe some of those games the order does matter, and maybe you like win double or something, but generally with Lotto, like for Mega Millions stuff, the order you're picking doesn't really matter.
There's been a horse racing game, you can see it on TV.
Oh yeah, it's 3D, and it's fake.
Like the horses we run.
Oh, the one at the gas station?
Yeah.
I'm sure it's just a simulation of a horse race.
It is.
It's just betting on a horse track. It's one of the most famous ways that people bet.
It's the corner of the
No,
horse
Daddy,
track,
it's
go to the gas station.
horses racing.
Yeah, they say
all
you
you
know,
let you
race
bet
on
on
it.
it.
They put it going to the gas station.
No.
So, you don't have to write this part, guys. I just put this here for you to read, so you do not need to write this, obviously. I'm just going to give you the formula for this example. And again, do you need to rewrite all this stuff here?
No.
Okay, it's the same thing we had last time. Choices and R. So what's important right now is this. That formula and maybe the example. You need to annotate, okay? Make sure you're annotating or using shorthand with your notes. If you're printing the notes, you don't have to, but you need to know this formula, yeah. It's one of the ones you need to know. All right, so for our first example here, you order a 3-scoop ice cream cone like we just talked about. Let's say the store only has 10 flavors. How many possible combinations can you order? So we start. Is it a combination or a permutation? Clearly, right? Because the word is here. Turn around. Come on, guys. John, turn around.
I remember
John.
I'm writing the notes.
Okay, I know, but you're just talking at the same time. I'm trying to hear her.
Isn't this like finding outcomes?
Yes, it's finding all the possible outcomes. That's exactly what it's doing, which is similar to probability. Remember probability? We found the total outcomes in the denominator and the possible winning events in the numerator to get the probability. This is finding all the outcomes. That's exactly what it's doing.
I remember like in elementary school we used to do like I think it was like 10 papers, and then we used to do the lines.
And you make a tree diagram and stuff. But for this example, that's good. But for these examples that we're doing, making a tree diagram, you'd have like 250 branches on it. But you're right. What Ashley is saying is, remember tree diagrams, guys? We made a sample space for your outfit. You had like 2 pairs of shoes, 2 pairs of pants, 3 shirts to match up. You had 3 choices for shirts, 2 choices for pants, 2 choices for shoes. So you ended up multiplying all those.
I know, I like how you just
Okay.
that's cool. That's what it just
Yeah, he just explained it to me.
It's the most easy, it's the simplest
At
example.
the same time.
4 meals, appetizers, entrees,
I
desserts.
like copywriting that.
We should go to a Baskin Robbins to go to
Baskin Robbins.
That's a good idea.
You should go there and tell them exactly what they're doing. Let them know. Say, I'm choosing 3 scoops and you have 31 flavors. So technically, I could choose this many combinations. And then they're like, what?
Sir, what do you want?
I
don't like
You have to say, well, it's going to take me a while because there are X amount of combinations I have to think about.
That's when they probably put ice cream in your face.
They're gonna be like, please step aside.
So we got combination. Can you repeat a flavor of ice cream when you get it at the store?
Yes.
Yeah, sure you could. You get the same flavor 2 times. Okay? So repetition is available.
Baskin Robbins kicks about my house with blue.
I've never eaten there, actually.
Repetition can occur.
There's a Baskin Robbins right? What?
Right on the one.
So,
What kind of-
what is my n value in this problem?
10.
10 because there are 10 choices or flavors. How many scoops do I get? In this one I get 3 scoops. Okay, there are 3 scoops. So, for this problem, all you're going to be doing is simply plugging into that formula. That's it. Okay, so go back to your previous formula. We've got By the way, here's how I do this, or here's how I memorize it, if it helps you guys. Jason, come on. The way I memorize this is I look at the problem, okay, and I know it's going to sound weird, but this is the way it worked for me. I just take my R and I move it down here. If I can remember to move my R, what am I left with up top, really?
Plus -1.
Or just n minus 1, right? And isn't that what's on the bottom there? So the easiest way that I remember it, it's not a mnemonic or a technique, it's just what I did in high school, I remember. I took this R, I moved it down here, and then I said, all right, in my mind, remember what's left over. And I knew that n minus 1 was left over, so I put that down there. And then I thought of, which is not true, I thought of this factorial as if it's being distributed to both. But you can't do that with a factorial. So I'm just telling you what I did to remember. You come up with whatever you need to do to memorize this. If you want to write a little, I don't know, sentence that has a word with n, r, the number 1, r, n, the number 1, that makes sense, go ahead and do that. You can share it with us if you'd like. Come up with whatever you need to do. Yes, we're going to do that now. So we got n plus r is 13, minus 1 is?
12.
R factorial is really just 3 factorial. N minus 1 factorial is 9 factorial.
Is that 3 times?
Okay. Now, the factorials are very, very interesting. You can't just say to yourself, I'm going to multiply these two together. Because then you're going to end up getting 27 factorial. You did 4. I thought of it 36. You'd end up getting 27 factorial, which is not true. And let's prove that real quick. What does 27 factorial really mean?
Oh, I know what 27, 26, 25, 23, 24.
But what is this really? This is really,
It's the 3 factorial and then...
9, 8, 7,
does that look like 27 factorial to you?
No.
It's not the same, okay?
6, 5, 4, 9,
So that's what's going on the bottom. Up top, same idea, right? Do I want to do this every time, though?
No.
I absolutely don't want to do this every time. So we use the factorial on my calculator in a minute to do this. But let's take a look. See 9 through 1, everybody? They cancel with all this, don't they? So what's your actual answer?
12, 11,
Again?
10 over 3, 2, 1.
And theoretically, we could just cancel right now to make it easier. 12 over 4, what does that become? 12 over 3. 4. 10 over 2.
5.
So on the bottom, I'm left with all 1s, right? So does that matter? 5 times 4 is
20.
20 times 11.
122. 121.
20 times 11?
What is it? 220. So there are 220 different combinations you can get of ice cream if there were 10 choices and 3 scoops. Now, imagine there were 31 choices. How many more? There'd be a lot more, wouldn't there? A ton more. Now, I don't want to do this every time. I want to take this expression and plug it right into my calculator. 12 factorial over 3 factorial, over the quantity, 3 factorial times 9 factorial. So let's go to our home screen. Now, I want to do 12 factorial in my numerator. So you don't have to put a parentheses, but I'm just going to suggest that you do. Okay? So the numerator is 12 factorial. I type in 12, I go over to, I hit math, I go over to probability, see the factorial number 4? Press number 4 now to get the factorial up. There's 12 factorial over parentheses. This is going to be 9 factorial. It was 9 times 3? Or 3 times 9? Same. Multiplication is commutative. So 3 factorial, math, go over, hit the number 4 again, times, oops, what do I need in the beginning here? Another parentheses for my denominator, times 9, math, over, number 4, close, close. How did I do what?
Little, you fixed it.
Oh, if you want to insert an extra parentheses, you go over to the location you want to insert it in. So say I wanted to put another parentheses before this one, John. Before this one, I go up to it, I press second insert, and I press parentheses, it puts another one beforehand. If I want to get rid of that one that I just put in there, I go back over to it and press delete. It gets rid of it. Okay? We get 220. No, we don't. So, for example, let's do the same thing. Let's do it this way now. Okay? But if you're going to do this, guys, the reason I put all those parentheses is because you definitely need parentheses around your denominator. Because you're dividing by, again, you're dividing by the product of two numbers. You're not dividing by 3 factorial and then multiplying by 9 factorial. If you forgot those parentheses, that's what would happen. Okay? But for this example, again, as Luis said, we don't need them around the factorial. I was just trying to be safe there in the first case. So when you do this kind of stuff, when you go into your calculator, make sure that you experiment with it. That's how I learned most of the stuff about this. Like, you know when you square a negative number, how you need the parentheses around the negative?
Yeah.
Again, that's one of the little tricks that a lot of people forget. They put -2 squared. A lot of people try and do -2 squared. And clearly it's +4. We know that. But if you just do it like that, what does it show you? -4. So you need your parentheses. So until you're sure that the parentheses don't have any effect, put them there to be safe. But then once we notice that we don't need the parentheses anymore, we can drop the parentheses that were here. Remember there were parentheses here, here, and here before. But we don't need those parentheses. Okay? Again, we don't need them, but we do need the parentheses around the denominator. Alright? Let's go on to the next one. Let's go on to the next one. So, combinations without repetition. Without repetition. Again, the most common example we just talked about a minute ago was lottery. Okay, because the order does not matter, and you're not going to repeat one of your answers. Again, the order doesn't matter. The order doesn't matter here. You're not going to be repeating one of the answers. Because once you pull one of the lottery values out, it doesn't go back into that, container that you're going to select from. Once you pull out of the hat, it remains out of the hat there for lottery. Luis. Here you can, yes. You don't technically need it, but no calculator. Oh, guys, when I put no calculator, I mean no permutation or combination key. That doesn't work, sorry. So just to clarify that, thank you, it's a good point. In the last example, I know you're writing. In the last example, we wrote down no calculator, right? But we used it for the factorial. When I put no calculator, I mean you can't use the combination function on your calculator for this. But for the one that we're about to do, without repetition, you could simply use the NCR function on there now. Okay? Again, no calculator with calculator is referring to using permutation function and combination function on your calculator. So for this problem, we have to ask ourselves, how many possible 3-number lottery tickets are possible if you're choosing from a basket of 10 lottery values? So, how many choices do I have? How many slots do I have to fill?
3.
So isn't it the same as the last problem?
Only there's repetition.
Without repetition. So stop for a second, please. Stop for a second. Think before you come up with an answer. Before, we had 3 slots to fill, 3 ice cream choices to pick, out of 10 choices. And there was available to repeat. You could repeat in that problem. Now we can't repeat. Are we going to have fewer or more possible outcomes? Fewer. Why? Because you can't repeat one of the values. Once you choose one of the lottery balls, it's done. You can't repeat it. So you have fewer choices for the next possible slot. Okay? Again. So this number must be less than the other value we just got. Because it's the exact same scenario. It's identical. But now we have no repetition. Without repetition. Okay, and again, this is a combination problem. So what do?
Plug in.
Let's plug it in, please. 10C3. The formula, in case you would like to know, and I'm going to write it down, because some of you might want to use this, you're welcome to, is the same exact formula as permutations, but simply with an R factorial up front. Remember, permutations without repetition, you don't need to memorize that formula either. You don't have to. But it's the same thing as combinations, but for combinations, there's this additional R factorial in the denominator. Okay? So it's 10C3. Because we're doing what kind of a problem here? Combination. We go to our calculator. We type in 10. We hit math, go over. But now we go to choice 3 here, because we're doing combinations now. So choice 3, the number 3, 10C3, and very good, it's 120. 120 here. Okay? The only difference with the permutation, if you did the permutation here, you wouldn't have this R factorial, which is really 3 factorial here. So for permutations, you're going to have more possible arrangements than combinations for this example. Again, for permutations, this would not be here. So your answer would be not just, what did we say, 120? Would not be 120, but your answer would be bigger than that, because you're dividing by 3 factorial here. Okay, but this is here because we're doing the combination. So that is important. Okay, but just remember, permutations and combinations are identical without repetition, except for that R factorial. All right, before we get to the homework and start some of those together, just to summarize, here's your summarization if you want to write it down. It might help you make a table. But again, here's what I want you to add. Use calculator. Again, so the formulas that are needed that you're going to need to know are this one, and this one. The ones that say use calculator, you don't really have to worry about those formulas. And you really don't need to, because you can simply use NPR and NCR in your calculator on a math function. Okay, so again, if order is important, or if the positions are important, then you're on the permutation. If the order is unimportant, you're at the combination. Then within each of those, you can and cannot have repetition. So how many cases do we have? 4. Because there's 2 possible, combination repetition, a combination permutation, and then repetition without repetition. 2 times 2 gives me 4. Okay, so again, please, you don't need to memorize those formulas with a calculator. It is useful to know them, but please don't waste a lot of your time on them. Spend more of your time practicing these problems for homework. I'd rather you do that than memorize. So I'm going to pass out your homework, and what I want to do together is maybe a few of these and just go over whether or not it's permutation or combination and whether or not repetition matters. That's the hardest part for these problems. So what I'm going to do is I'm going to hand this out, and I'm going to give you about a minute to do specific ones, and then we're going to go over them quickly. Okay, and I'm going to give you a minute just to decide what it is. Not to do the math, but just to decide the kind of problem. Please look at number 1. Please look at number 1 and decide. Well, actually, everybody read the directions. Take a minute and read the directions because they're long. You can read through them. erasing the first one?
No. It's up in our homework.
I wanna move, man.
Mr. Smith?
Mr. Malachek would beat you.
Erase? No way.
Do you see how small that man is? He's aerodynamic.
If it's a long distance, short. The short distance,
Tell you.
I wanna see
But not
that.
Aerodynamic.
I wanna see that. I think Mr. Smith would win. Like 50 steps up there is like 2 steps up here.
And he needs
It's all
to
gonna take like a while to get there.
What number?
I got Brandon, I have no problem. I run on it for a while, it hurts a lot.
Last time at one time, you're like,
Alright, so first, state whether order is important or unimportant.
you glue things up.
Okay, so determine whether they're important or unimportant. Then decide if anything can be repeated. Okay, so name the problem as either permutation with repetition, permutation without, combination with, combination without. And finally, find the answer. So for the first one, we got 3 people racing. How many different orders can they finish the race? So does the order matter? Clearly, because we're wondering how many orders can we finish, right? So whoever comes in first, that does matter. So order matters. So what kind of a problem do we have? So write down a P on the side, please. Okay. Can I come in first and second place?
No.
Can I come in second and third place?
No.
No. So is there repetition?
No, without repetition.
So permutation without repetition. So what should you use? A calculator. Very good. Again, permutation without repetition, you can use your calculator.
It's 3
3P3. You have 3 choices to fill 3 slots. And 3 choices to fill
Who got sick?
3 slots. Say again? You should get 6 here. Why does this make sense for this problem? Without a calculator, let's just prove it. How many people can finish in first place, guys?
3.
How many can finish in second place?
3.
2. How many can finish in third place? What, 3 times 2 times 1?
6.
So you don't need a calculator here, really. Okay, you really don't need a calculator here. All right, let's go to number 2. Number 2. A 2-sided coin is flipped 8 times in a row. So I keep taking a coin and I keep flipping it. How many different outcomes are possible if the order of the results is important? Is it permutation or combination? Because it says the order is important, not unimportant. It says the order, says if the order of results is important, how many different outcomes are possible? Or number 2. So since the order is important, it's a permutation. But guys, why is it repetition? You keep getting heads or tails every time, right? Doesn't matter, 3P. So now, can we use our calculator? What was our formula for this one? N to the R. Okay? It's a permutation
What I meant.
with repetition. Or did I write it wrong? Hold on.
Look what you do.
Oh!
Oh no!
Damn. That's terrible. Yeah, I know. Go to your notes, please. That would have been a very, very bad thing. Thank you.
So we
I'm
gotta
going to switch that. Because that's all your homework. Switch these 2 words, obviously. Switch these 2. Again, permutations are these 2 possibilities here. And we just did it, I know that, and I totally screwed that up. But these 2 are combinations that we just did today. This is what we did yesterday.
So the bottoms are columns.
Yes, the bottoms are combos, the tops are permutations. Switch the whole thing. Switch the word combination, order, unimportant, all the way down here. Switch this whole thing up there. Okay? I apologize. Thank you for pointing that out. Oh man, that's upsetting.
I messed up, oh my gosh.
That doesn't even make sense. We did permutations first. Why not have written combinations?
I don't know.
I must have been thinking about combinations. All right, so let's go back. Sorry. So n to the r in this case. What was n? How many different choices do I have? 2. It's heads or tails, right? That's my choices. But how many times am I going to flip this coin?
8.
8 different times. So there are really 8 slots to fill, each of which could be heads or tails. And the order does matter. So we have 2 to the 8th, which equals? Very good. It's good to know powers of 2. 2 to the 7th is 128, 2 to the 8th is 256, 2 to the 9th is 512, okay? 20th?
I don't know, 20.
You can do up to, once you get up to 512 and then 1024, that's pretty much where you're going to stop because of capacity of hard drives. That's where they come in. 1024 megabytes, that's what a gigabyte
I
really
don't
is.
know what that is.
Okay. For those who like computers, I'm trying to make an association so you know, powers of 2 are how the memory works, okay? So it's powers of 2 moving up in your RAM.
It looked like you were a hacker in high school.
What?
But it didn't have computers.
Let's go to number 4, please. Number 4. Number 4.
He still has
Matrix.
Number 4. Can I get somebody to read, please? Vanessa, also read us number 4.
Your boss wants you to.
Listen. Sorry, guys, you need to listen. She's reading. We're skipping number 3. Go to number 4.
Your boss wants you to choose a committee of 5 people with a possible 10 candidates. How many different committees could you choose?
What do we got? Somebody raise their hand and tell me. Either Leone, permutation or combination.
Permutation,
Why?
because it doesn't matter what order you
You said the second part correct. It doesn't matter. So it's combination.
pick. Oh,
Okay? The second part, you're right. The order, it doesn't matter if I pick 5 people randomly and I say, John, Derek, Brandon, Naomi, Daniel to help me with the activity. Or if I say Daniel, Naomi, Brandon, Derek, and then John. It makes no difference what order I pick them in. They're still going to be part of the committee, right? So order does not matter. Thus, combination. Combination. Now, can I pick John for the committee twice as much as I want to?
No.
John, you're a smart guy. I want to pick you to help me out with this twice. I can't do that, right? So is there repetition?
No.
No repetition and combination. So yes, calculator, good. Combination without repetition tells me to use my calculator. So how many candidates do I have to choose from? 10. How many do I choose? Good. Okay, 10C5. Please plug it in your calculator.
Thanks, Sharon, for answering.
Trayvon is correct. If you want to check, it is 252.
Liar.
2 more to go. I want to do 2 more. Let's do number 7. Then we'll jump back and do
number 5.
number 5.
We didn't go ahead and do the
Number 5 was a good one. Number 7. No, not number 3. Sorry. Number 7. You order a 2-scoop ice cream cone at the local store. We did this already in class. All right, let's do number 5. Number 5. DNA is arranged. DNA is arranged using 4 different bases. I don't know what happened.
I pulled the chair.
Using 4 different bases, which are named by the letters A, C, T, and G. Do you remember this biology?
Yeah.
For a minute. Make believe you remember this.
We did what? To what? I remember it from Bill and I, the science guy.
What did it? C and G go together and A and C go
And
together?
F through a parent. All right, so the problem says
We had the best biology.
the order of the bases. The order of the bases is important because it determines which gene an organism will carry. A particular gene is determined by 10 bases. 10 different bases. Out of how many do you have to choose from? 4.
So it's
Careful.
4.
We have 4 to choose from, right? A, C, T, and G, but we have to choose 10 of them. How many different ways could the bases be arranged in the 10 spots?
It's
Permutation.
scientifically
repetition.
inaccurate.
Let's slow down, one at a time.
Permutation.
Why?
Because location doesn't matter.
It says the order of the bases is important. So start, permutation. Next, Derek, what did you say? Why do you know there's repetition here? Because it doesn't say it here. So you must, right? Very good. Very good use of intuition there, Derek. He notices we have 10 spots, 3, 4, 5, 6, 7, 8, 9, 10. And we need to fill every spot. But we only have 4 choices. So something's got to repeat, doesn't it? Even though you don't see repetition there. Think about it logically. There are 10 spaces, and there are only 4 things to choose from. So n is equal to 4, and r is equal to 10. 10 slots, only 4 choices, permutation with repetition. So can I use my calculator?
No.
It's with repetition, Juliet. Can I use my calculator?
Answer is
No, I cannot. Yeah, I cannot. So what must I do here?
And
Then
4, yeah, 4.
it's 4.
So it's always going to be my formula. We go back to our table in the right order, though, this time. And we know that this is really permutations. And we cite with repetition and to the R.
It's 1,048,500.
Class though.
Finish the rest for homework, guys. Finish the rest. We only got a few left.
Who's ready to go fill science?
I studied.
You need to
You're the only one who studied.
Thank you.
Why?
Well, it's not.
I'll make sure to show.